Hello and welcome to the Home and Energy Chats. My name is Heather Chandler, and I am the owner and publisher of the Green and Healthy Maine Homes magazine. And every episode, we bring you industry experts to help you learn about creating healthy, efficient, and sustainable homes. And today, I am very excited to have Rob and Linda and Christy here with us today to talk about making the invisible visible, indoor air quality monitoring for homes. I've personally found um, monitors to be very empowering to me in my own home and have helped me to make adjustments in both my home and office, learning when CO2 gets too high, for example, and also helping me to understand how different activities in my home impact various air quality measurements. So I hope that you have a chance to learn the same today. In a moment, I'm going to officially introduce our panelists. But first, I want to say a special thank you to our season sponsor, Royal River Heat Pumps, a locally owned and operated company that is nationally recognized for heat pump excellence and 100% committed to the highest standards of quality installations, service practices, and customer satisfaction. And you can learn more about them online at royalriverheatpumps.com. And now a little bit about us. Green and Healthy Maine Homes is dedicated to inspiring healthy, efficient, and future-ready Maine homes. In addition to these home and energy chats, we also publish the Green and Healthy Maine Homes magazines. We host the Green Home and Energy Show, which is coming up March 28th in South Portland. That's a great day-long event with workshops and exhibitors and EV test drives. And then we also have a Green Home and Design Awards event in the fall. And you can learn more about all of these things on our website at greenmainehomes.com, where you will also find a program of Maine home professionals who specialize in healthy, efficient, and high-performing homes. And now it is my pleasure to introduce our panelists. Linda provides residential energy and air quality consulting services through her firm, Linda Wigington and Associates, based in Waynesburg, Pennsylvania. She is the founder of and has been associated with the Affordable Comfort Conference from its inception in 1986 through 2013. As program director, she convened the program committees and confirmed the agendas for over 50 North American and regional conferences. These events have been instrumental in promoting an integrated approach to health, safety, durability, and energy performance. Since 2014, she's been the team leader for the Reducing Outdoor Contaminants in Indoor Spaces initiative, which you may hear us refer to as ROCUS. It's shorthand. This is funded by the Heinz Endowment, and as part of the ROCUS low-cost monitoring program, she directs data analysis efforts and provides oversight for indoor air quality interventions, including the portable air cleaners and induction cooktops, as well as the high MERV filter inquiry. A BPA journal article, Raucous and Linda Wigington's Quest for Healthier Indoor Air, summarized her work. Most recently, she is under contract with the Maine Indoor Air Quality Council to implement their monitoring pilot program, which is designed to support those with uncontrolled asthma. So we are so thrilled to have you here with us today. Welcome, Linda.
Thank you.
And next we have Rob. Rob is a longtime lover of the environment, interested in the human interactions with our natural resources. He joined Raucous in 2017 from Boston by way of Rhode Island, Canada, Pittsburgh, and now Maine. Welcome to Maine, Rob. He has held previous positions with various federal and state agencies, as well as nonprofit organizations. His contributions to Raucous include running, analyzing, and fine-tuning aspects of the low-cost monitoring project, data management, participant outreach, and equipment logistics and maintenance. His other Raucous responsibilities include social media support, website maintenance, and lead generation. And most importantly, Rob is the main troubleshooter, always willing to tackle a new technical problem. Always great to have someone like that on the team. So welcome, Rob. So happy to have you both here with us today. And I would also like to introduce Christy Crocker, who, if you have joined our Home and Energy chats in the past, you may have met her on several occasions. She is an alum as well as a member of the Green and Healthy Maine Homes Advisory Panel. She has served as the executive director of the Maine Indoor Air Quality Council since 1999, where she manages the council's administrative, education, policy, and communications work for healthy, productive, and environmentally sustainable indoor environments. Prior to her work with the council, Christy served as the continuing legal education director at the Maine State Bar Association for 14 years. She's a graduate of Colby College in Waterville and both lives and works in Hollowell, Maine. So welcome, Christy.
Thank you, Heather.
And at this point, Christy is going to be monitoring our session today. So I am going to turn it over to you, Christy, and I am very excited to see the presentation.
Great. Thanks, Heather. I'm going to be hanging out in the background here, monitoring questions. So if you do have a question for Rob or Linda, please don't hesitate to type it into the Q&A box, which is on the control panel at the bottom of your screen. Um, and we'll also have some time after today's set, after the presentations for some Q&A with Rob and Linda directly. And if we're not able to get to any of your questions throughout the presentation, Heather's going to be sharing my contact information. You are more than welcome to reach out to me directly at the Maine Indoor Air Quality Council, and I'll make sure that we get the answers to your questions so that you don't leave here feeling as if something is still niggling at you, that we want you to get what you need out of today's session. So I'm going to stop there. I'm going to pass it over to Rob and Linda and look forward to seeing everybody in the Q&A box.
Thank you, Christy. It's such a pleasure to be working with folks in Maine. We've gone back a long time. So a little bit about ROCUS. We're a Southwestern Pennsylvania initiative, and we have been doing low-cost monitoring cohorts for 10 years. So over 600 folks have been involved in those cohorts, 3 to 4 weeks long. We actually probably have 12 or 15 folks that have participated from Maine. But a key part of that has been building on what we're learning by doing those cohorts with folks, one-on-one engagement, and then the data collection, analysis, and feedback, and understanding the implications. But a key goal of starting the low-cost monitoring cohorts was to understand, do low-cost monitors empower occupants, and how do you help them do a better job of empowering occupants? So that's sort of what our context is. And this is just an example of our kit. I wanted to convey that we selected products based on our very particular needs, which meant we were using multiple monitors in a given home, like 3 dialos and 2 radon and all that. And what we have for our purposes isn't necessarily appropriate for others. It made a whole lot more sense for us to have single source monitors. And we, reuse them many, many times. So just wanted to convey that in a sense that, well, the context of our experience, but also that we have not focused on purchasing every available monitor that's come along and trying them all out. We've tried out a few, but we are not, we are far more knowledgeable about the things that we have specifically focused on and understanding the results of the monitors. So 3 meeting objectives. One was for you to gain a clear understanding of what low-cost monitors are designed to measure. Here, example of how monitoring has informed homeowner decisions, and then have a better understanding of what questions to consider before purchasing or using a monitor. So this is EPA's definition, and I just want to point out this is a good resource. So check out this link. Basically, low-cost monitor is a device that uses a sensor and other components to detect, monitor, report on pollutants. And then they say they can provide a way to get information about specific pollutants that may be in indoor air. And therefore, they can detect one or more of a combination of things that should be acted on. For the purposes of our presentation, we are focusing on monitors that would be used with a focus on indoor air. There are lots of initiatives that look at um, uh, outdoor pollution as consumer and citizen based, but that's not our focus, so just so you know. So why monitor? Building on what EPA says, what we find that people often contact us because they want to know if they have a hazard present. They're interested in investigating health symptoms because they think there might be an environmental connection. Certainly, the whole idea of verifying whether or not equipment is performing as expected, and figure out if it's not, why not. Another would be gaining insight on how to then operate that equipment effectively. Some folks just want to have a long term, and it makes a whole lot of sense to have some monitors over time to know that you don't have a problem. Um, and to us, the impetus to take action is the bottom line. So that has been our framework, is we wanted to find out how monitors could um, result in better indoor air quality. And the key quandary is then, do they empower people or do they overwhelm people? Or do they provide false assurance that everything's okay? Or do they just wreak havoc and cause confusion and anxiety? So there's a sweet spot in the middle of these, but are definitely, and building on what Heather said to start with, indoor air quality monitors can be a powerful tool to really support a person gaining an understanding. And I think that's a really interesting way to think about their role, is that um uh they're a an a, in a sense a trainer, a teacher, and it's just, in that case, it's just very important to recognize that there could be times that they're screwing up. So the challenge is, how do you interpret and make sure that you're understanding the limitations and not giving too much credit for the signals you might be getting. So that's sort of the part of the quandary there too. So a bunch of monitors on the market. This is just, a sampling of a few. We have experience with the AirThings View Plus and the Purple Air Zen. Um, this is the Haven room air monitor, has some interesting features, but there are many, many, many. And to me, that's one of the biggest quandaries, is there are so many, and how would you decide what to do? So we'll probably be addressing that more in the question and answer period. There are some neat viewer options that one of our team members had identified these as the things that he thought were the things he would want the most, and that was the opportunity for the monitor to communicate directly to you, but also have the opportunity to look at an app or some other way to see things. So the dual view option was really a value to him. The idea of seamless Wi-Fi connectivity. In other words, automatic uploads, not something you have to think about doing every regularly. The idea of check-ins, some of the monitors do provide feedback and give you a weekly check-in based on the information you've asked. And so to say, here's a summary of your monitor readings. Um, and then another one is the idea of community mapping, or the idea of, I think this could be broader than just thinking of visual mapping, but rather the idea uh, that if it's part of a community of monitors, then you've got this opportunity to learn from others, whether it be a virtual community that's nationwide or worldwide, or whether it's a community that's a bunch of neighbors and friends. But the idea of collaborating with other users, I think, is really key. So much more useful than using a monitor solo. Okay, so some of the questions are, what are the important parameters that they measure? What thresholds should be used? What should I buy? And if they say things are bad, what should I do? How bad is bad? So just things to wonder about. Okay, so in terms of monitoring indoor air quality, there's sort of, you could come up with, this could be a continuum between established and not there yet, or we came up with three buckets. So people will probably disagree in some cases, but there's a basis for why we said established are things that have been monitored for quite a while and have basically proven themselves to be incredibly useful at understanding these particular pollutants. I'll be going into more detail on these. These are emerging in that you can buy them. There's a bunch of there are many low-cost monitors that include the measurement of these pollutants. But there are many questions about their reliability and some sort of more limitations on what application you should use them for. So there needs to be a little bit of a humility factor if you're using these indicators to guide major decisions, I guess would be the best way to say it. And these are sort of exciting in that there's a lot to be learned. There's certainly benefits, but not there yet is a good way to summarize it. Okay, so radon is, I think the statistics in Maine is what? 1 out of every 3 houses has elevated radon. We only have 40%. Well, no, yeah. Well, that's actually more. Yeah,
It's 2 out of
40%.
3 in Cumberland County.
Okay, yeah. So radon is common, very, very common. And it's relatively inexpensive to address. And I mean, what, $1,000, $1,500 is the cost of a typical system. So it is, and yet typically it is not addressed unless somebody knows it's a problem. And most people, in most cases, it's not checked for unless you've got a real estate transaction. That's probably 90% of the work that radon mitigation contractors get. So the bottom line is it's a no-brainer. I mean, everybody should be monitoring their home and make sure that they don't have radon. And it's not just a one-time thing. And this was and our participants really like the radon monitor we use, which is just it's a $150 monitor that's not plugged into anything. Um, Batteries do need to be changed every year or two, but there are other monitors that are Wi-Fi enabled and you can see them on your an app. So there's all kinds of ways to look at radon. But the key thing is we have a survey, and when people come into the cohort, they answer some questions. We were surprised. 34% of our participants had previously tested for radon. So we did some analysis and we assumed obviously that those 34% would not have as much radon. We were astonished to find that there was the same percentage that the percentage of folks, and it was again, that was about 30% of those folks did have radon above 4 picocuries per liter in a 3 to 4 week monitoring period. So that was like a real head scratcher. And there are a number of reasons for that. But a whole lot of those tests were done during a 1 to 3 day uh, real estate transaction. And who knows, was somebody cheating? I don't know. It could be. Or was it misinterpreted? Or was it that the 1 to 3 day duration wasn't accurate? All I know is that this, our recommendation is that you don't just monitor once and assume it's done. Bottom line is you should have, or at least access a radon monitor and monitor for, at least a month every couple years, or just have it in place all the time. But easy, cheap, they should be calibrated, so it's not just something you leave for 10 years. But radon mitigation is pretty proven intervention. And I realize in Maine you also have radon from water, which we don't, but most of ours is strictly from the soil, but very much worth monitoring. So slam dunk, number one.
Linda,
Yeah.
uh, you had asked that I bring up the question that had come in prior to the webinar regarding radon, since when you're monitoring, you're going to notice that your radon levels go up and down, and they may vary from day to day or week to week. And so the question was, how do why does that happen, and how does, the monitoring maybe assist you in understanding what's going on with radon?
Well, I think monitoring for radon with a monitor that does provide that 1 day or short-term feedback, as well as the long-term average, will will give you confidence not to trust a short-term read. But so for that, I'd say the answer is all the recommendations on when action should occur are based on long-term exposure. In fact, lifetime exposure. But the 4 picocuries per liter is an action level by EPA. World Health Organization says an even lower level. But the bottom line is don't trust the short-term reads. But as much as we've looked at those short-term reads, you normally can't other than a major weather event like a storm rolling in, a major change in atmospheric pressure, you definitely can see some effects. You definitely see effects when there's snow cover and the ground is saturated versus dry. But there's so many confounding effects that drive radon that when we've had people try to figure out, and when we've looked at it more closely, we just say it's confounding. Don't even try to figure it out. Just consider it interesting. It's not necessarily enlightening. So long answer to that question, but a great question. So CO2 is not hazardous in itself at the levels we experience in homes. It's it does cause some impairment at higher levels. Um, there's some real controversy regarding what the right level is. There for the longest time it was 1,000 parts per million. Now, with COVID and other things, there's recommendations that people function better to have 800 parts per million, 700 parts per million. Initially, and our context was that CO2 is thought of as being a function of an indication of how tight a building is or how the density, the occupancy. So in lots of buildings, if you have 100 people in them, the CO2 will go way up. If they're empty, it'll go way down. So all these things interact, and that had been our primary focus. And we always had one CO2 monitor in the bedroom. Our surprise was when we added a second monitor, told them to put it in the kitchen. All of a sudden, people were seeing, and it only makes sense. We know it's no brainer that CO2 is also a product of combustion. So the interesting thing is that a lot of the CO2 we saw, which was nighttime CO2 in the bedroom, was actually the CO2 that, or not, yes, CO2 that had come from the kitchen because they cooked in the evening, and that's usually the biggest spikes. But the interesting thing about this is CO2 can be a powerful motivator for taking action and understanding more about what's going on in your house. But it's not like a short-term reading is going to be that useful. I mean, even short-term, even looking for a couple weeks, it's very important to recognize that CO2 levels are going to vary a lot with outdoor conditions. But the idea of using CO2 in order to drive and understand, do I um, do I is a ventilation system that I invested in working, I guess would be one way to put it. It's important not to assume that just because your house has low CO2 that you don't need that you have clean air. So that's an important qualification. But there are lots of CO2 meters on the market. There is an issue of calibration and drift and all that. So the key thing is if you're buying a CO2 monitor, it probably makes sense to have multiple ones, or at least have friends with multiple ones, at least do some comparison and recognize that they're not going to be, reliable within 50, 100 parts per million. But the idea of our experience was really interesting. And what we saw was when people could see the effect of cooking, and even though we stressed, okay, CO2 is not in itself a hazard at the levels we're seeing, it's better if it's low, we still saw people take action because they could see that the gas cooking, was really causing elevated CO2. So I think that's really interesting to think about how a monitor that can serve as an indication of other things can help drive action, which I think incredibly valuable. But the challenge is don't misinterpret what you're seeing. Um, any questions on CO2 that you want to address?
No, there was a question that had come in before the session regarding um, uh, do you have a recommendation for a good low cost CO2 monitor?
There's only one case where I'm making a recommendation on a monitor. There are some out there, but I'd rather not make
Okay,
recommendations.
okay, fair. That's
But I'll
fair.
do it offline. Be glad to do it offline.
Yeah, okay. No,
Okay.
that's the only other that you've already answered the other ones, so you're
Okay.
good. Yeah, thanks.
Okay. Temperature and relative humidity. Hey, these things have been around forever. I mean, inexpensive, fixed devices that you sit there. Everybody, relative humidity varies, so calibration might be off. But the key thing is temperature and relative humidity is often included with other monitors because actually the other monitoring functions are only supposed to operate within a certain range. So it's important to know that the temperature and relative humidity is within that range. We recommend to use it year round. It can be incredibly valuable as an early alert because like my um, daughter had a dehumidifier quit that they hadn't realized it quit. They weren't in the basement that often, and all of a sudden, they had a major issue with very, very high RH. And the thing is, if they had been monitoring, it'd been very easy to see that. So it can be a very good early alert in spaces that you're not in. So this is where the connected devices and having a sense of, hey, I've got really high RH in the basement and go look or in the crawl space, so, so critical. But but the important thing is that air temperature does not equal surface temperature. It's a surface temperature like in the corners or in the cold spots where you got all kinds of stuff piled up that might be the coldest spot, and that might be where you have a dew point and mold. So it's important to recognize that, yeah, making sure that the air temperature is within an expected range is important, but the you need to recognize the limitations that that's not going to tell you that you don't have a hidden mold problem that is basically in disguise. And I don't think there's any better resource than the council for all kinds of great information on mold. So, and some really neat new stuff. Now, this is the one case where I'll make a recommendation, but carbon monoxide can kill and disable, and it can do that within hours, probably even faster if it's high enough level. We recommend that houses should have low-level CO alarms. And by low level, I mean reading 5 to 10 parts per million. But it's very important that if you have a low level alarm, that you don't freak out just because you have 5 or 10 parts per million. We recommend that you use it as an indicator that, oh, something's producing CO. I wonder what. I better understand that because it could be worse. There are two in particular that I know of that are sensitive to this level, CO Experts and CO Defender. This is one source where you can get them. You can probably get them on the web, all kinds of other places. But even if you have an all-electric house, you could always have a power outage where you're running a generator. Probably more people die of CO from generators than from backdrafting appliances. So yeah, get one. No brainer, slam dunk. So particles. Particles is the main thing that Raucous is focused on. So I'm just going to say a few things, and that is that we thought that we would see a really direct and easy signal. We thought that, oh, you put in a particle monitor and you do something and automatically you'd see an impact. This is a graph that this is outdoor data, is the green line, and the yellow and the red are our two indoor monitors. Look at and this is a log scale, so this is skewed. This is um, much flattened. But the bottom line is look at the effect and the interaction between indoor and outdoor. Big difference when the um, indoor, when the outdoor is at its best versus at its higher over here. What this means is if you're using monitors to try to get a clear signal when you're on particles, if you don't have some sense of what's going on outside, you could be pretty misled. So that's the takeaway here, is recognize the impact of outdoor. And these aren't houses that um are leaky. I mean, this is closed condition houses. This was just this February, and this is a relatively new house. In fact, those houses, it's a cleaner signal because you don't have all kinds of other activity going on. This house had filtration and everything. So really important to recognize that. Um, I'm going to say one more thing about particles. So particles are not going to kill you. Particles are, well, yeah, particles do kill you. They kill hundreds of thousands of people a year worldwide, but there's a huge group of class of air contaminants. Probably most of the exposure that people have to particles that are outside is when they're in homes. So, and that was the impetus for Raucous. So, was how could we in our homes protect ourselves from outdoor pollution? But there's so many sources inside as well the neat thing about particles is a huge opportunity to have an impact. So in terms of, of learning a lot about how to make your house healthier, it's probably it's just a significant opportunity. What we found is it really helps to have a monitor that measures and counts, not in mass. In other words, not PM 2.5 or PM 1.0, but particles as a count. And there are a few that do that. One is purple air, another is Dylos, another is the Haven room monitor. We're looking to see how many more do that, but it's really important to think about that there's a real difference between outdoor air quality and indoor air quality. And when you're making that transition, we can't just take the standards for outdoor air quality and move them inside. So
So,
now we're going to go give
yeah,
Rob a
Linda,
chance.
there were a couple of questions that had come in before the program that are relevant to the particle count, specifically around wood stoves in the winter and what specific problems associated with wood stoves might be of concern and how might monitoring help that.
It'll help you realize that you really have to be good at loading your stove, or you're going to get a slug. And you can smell it anyway. You often smell some wood smoke in a house if you're not making sure that you've got a draft, establishing a draft before you open the door. Make sure you don't have your kitchen range hood on when you open the door to load a stove. Um, we've certainly seen much more going on as you tend the fire than with a fire operating. But also, we have seen certainly you can have pretty significant outdoor smoke, wood smoke, where neighbors are affected. So you really want to operate that wood stove well. Um, really dry wood, really smart about it. Um, um, yeah, we've had people reconsider the use of wood because they've seen the effect on on particles both inside and outside. But studies by CMHC showed that they did not see what they expected to in terms of it being an adverse effect for people heating with wood in their homes. Um, Fireplace is a different issue, but yeah. Any others? Now on to Rob.
Okay, so just wanted to apologize ahead of time. I kind of lost my voice over the weekend, so if I'm scratchy or clearing my throat, sipping water, that's why. Okay, so there's some limitations with certain pollutants. The interpretation of these issues, it's like what exposure period you're going to have, what is the threshold or the guidance level for that pollutant, over what period of time. There's calibration issues, meaning that if you set up a monitor, it's going to calibrate in a relative state, not necessarily to a true zero. So it'll be able to identify spikes and big dips and troughs, but the in between might sometimes be a little bit less accurate. And then there's all sorts of different metrics, like Linda was mentioning on particles specifically. PM1, PM 2.5, PM 0.5, those are all particle matter and then the size of the particle. So 1 is 1 micron in diameter, 2 is 2.5 microns in diameter. And that's all even against the backdrop of a different metric like count, like particle count. What is the concentration? Because those PM ones are usually mass-based. And with low-cost sensors, they're not really actually measuring the weight of these particles that are in the air. It's using more often an estimation of that. So there's a lot of different confusing aspects of low-cost sensors, and some of them fall up short. One of them that we get often asked about that we don't necessarily monitor for that often because of the variability and the hyper-specific changes that can occur is volatile organic compounds, so VOCs. So VOCs are a little bit tough to monitor for a few reasons. There's a bunch of monitors that exist on the market that are low cost that will give you readings for VOCs, but it inherently comes down to the method that makes the manufacturing process that makes the monitor, the design, low cost, is inherently its weak point as well. So A lot of these have accuracy that fades over time because the measuring tool on the inside, the sensor, is highly sensitive to begin with. And every time it interacts with a VOC in the environment that it is ultimately reading, it reduces its sensitivity a little bit. So in this case, if there's a really, really high spike, the sensitivity of that sensor overall will ultimately become dulled over time. There's also, like I mentioned with particles, there's algorithms. These algorithms are usually compensatory for the fact that the sensor itself within the monitor is impacted over time or fading over time or impacted by disproportionately by very large spikes. So the algorithms are a whole nother, variability to the accuracy of the actual readings. And then kind of the title takeaway of the slide, clean air crutch. Clean air is assumed to be present at some point in the measurement and the reading, and also the compensation, if you will, or the correction by the algorithm. So if you have a small room that you renovated and you used very high VOC products on, and you painted it and you primed it and you put in caulking and all this stuff, there may not really be clean air or true zero or close to zero readings of VOCs in that room at any time. And in which case, the calibration and the algorithms and all that are going to be affected and be less accurate. So just to give you an idea of what these technologies are. So this first column on the left is just the category column, but the second column in from the left, metal oxide, MOX, that is generally the technology that's used to measure VOCs. It's the lowest cost. It has pretty good sensitivity for ppm up to ppb, which is parts per million or parts per billion. It has low selectivity, so it won't really tell you which type of VOCs you're having. It'll just kind of give you an idea of total VOCs. And that's going to be, again, best for consumer levels to kind of just measure, are there spikes, basically, and is the level overall high and for how long? But the next best would be like photoionization. And these are definitely not low cost, but they might be in the sub-$1,000 category. And that is kind of a mix of the two ends. And the next one, which is kind of the important one, is gas chromatography, which is very high cost, can be tens of thousands of dollars, but it's going to give you all these different specific readings that are based on a much more sound technology. So even though you're not going to be using a gas chromatography monitor, I just wanted to kind of give some reference for what is being used in like an industrial or regulatory compensation with EPA monitors versus what you might be picking up online for a couple $100. Just digging into some of these big VOCs that are often, you might read news articles about them, or they're even listed as VOC levels that are emitted from certain products. BTEX is a big one. So it's benzene, toluene, ethylbenzene, and xylene. So these are all VOCs, and they're very abundant and common in the outdoor environment because they're often associated with petrochemicals and the burning of combustion or just presence of petrochemicals. But thereby, as Linda mentioned with the indoor-outdoor relationship, they're inside as well. And so there's a high degree of seasonality with these. They change from the winter versus the summer, and that's not only an outdoor context, but an indoor context as well. The levels indoors would be potentially higher in the winter because you have your windows closed. There's maybe less ventilation unless you have a product like an ERV or an HRV. And then in the summertime, maybe your windows are open, so it's ventilating more of these products that might be building up VOC levels inside, but it's hotter, and heat affects these greatly. So newer homes are talking about building products and paints, varnishes, even upholstery, stuff like that. Little known or little considered factor is that the newer your home, kind of the more poisonous it can be. Not always, but it can be the case. So also smoking homes, there's combustion going on that can be creating VOCs as well. And attached garages are a big one because unless you have an electric vehicle, generally speaking, there's presence even through residue and you know, not necessarily emissions, but there's presence of these VOCs in your garage. The metal oxide technology, like I mentioned, is kind of a repeat, but especially with these BTEX compounds, they fade pretty quickly in accuracy, and there's basically no selectivity between which type of VOC it is. For some other pollutants that are off of the VOC chain, in a different category, PFAS, those are big in the news lately, the forever chemicals. Microplastics, those have been, addressed for a while, but not a ton of regulation around them. There's a bunch of others. So in almost all of these cases, whether it be the VOCs that have some monitors that can test for them, or these ones listed here and others that don't really have much monitor, especially on a consumer grade low cost basis, what can you do? Well, basically, you're just trying to, first of all, be aware of them. Make sure your family is aware of them, or people you're living with, where their sources come from. Reduce those sources if you can, if it's feasible, if it's cost effective. There's some behavioral things like using ventilation more effectively and at the right time, critical timing for ventilation, like bathroom fans, range hoods, even open windows. Cleaning is a huge part of it because oftentimes things that make it in can react with other things that are already in there. And so if you keep things clean, there's less, there's more reliability on it just being straightforward and being able to control for that. Also, filtration is a huge one. We are big proponents of filtration, whether that be with your furnace, whether it be a portable air cleaner. And there's a link here that has some really good healthy home tips for relating to these.
Rob, one issue about that one is that
Sure, go ahead.
That many of those things are carried into that we're exposed to many of the things that we're not monitoring directly, specifically through particles. So particles can be the vehicle, or it might be that PFAS and microplastics are, nanoparticles or ultrafine particles. So addressing particles does a whole lot to capture many, many, many things. And that's why the filtration can be so critical to reducing your exposure to these things. But by all means, everything else. And the 10 steps to healthy home, Terry sort of came up with this holistic approach list, and that's what is based on. But check it out. It's great.
Okay, so yeah, good readings doesn't necessarily mean 100% of the time that there's good indoor air quality. Again, there are variabilities in monitor consistency, reliability, all that. And so there's a lot to be said about what we can't monitor, even if you have a monitor for that. So if you have a low-cost monitor for VOCs that goes down to parts per million, there's readings that go down to parts per billion, and it may not be picking up on that. Same thing goes for particles specifically, which this is a great highlighted graphic for that. So just to explain the graph real quick, on the left-hand side, the y-axis going up and down is particle count. And again, this is not mass-based, it's count, it's just concentration. And then across on the x-axis, that's not timing. So it's not a time series graph, it's particle size and diameter for microns, or micrometers, same thing. So oftentimes, most low-cost sensors are starting to be able to detect particles at this blue line running up and down. So everything to the left of that blue line, most all particle monitors that you're going to be buying at a low-cost level are not able to even see that. They only start detecting at that blue line. So you look at the concentrations, the highest concentration after that blue line is about 100,000 particles per cubic centimeter. But the highest total is 5 times that, basically, 4 and change times that. So that's something to consider, that even if you are monitoring for it, there's a lot that isn't being seen. And that's, again, why to go back to those approaches of 10 healthy home steps and, just stay clean, filter, ventilate, things like that.
Rob?
Any questions?
Yeah, just there was a clarifying
Yeah,
question.
go ahead, Chrissy.
Yeah, regarding what
Sure.
could you just clarify what you mean by point source ventilation? Is there an example of that? And there's some other questions too that I'm going to try to answer in the background here for you.
Well, and just in terms of ventilation, we're, I mean, if you're going to combine a point source and ventilation, a point source would be cooking on your stove or in your oven. Um, so that would be like burning food or just cooking food at a non-burnt level is going to generate particles and pollution in the home. Running the range hood, as long as it's ducted and it's extracting those particles outside your home, that's going to be a massive reduction in particles, both in the time that the particles are around and the total concentration of them. Same thing, like you think about it in a bathroom, turning on the fan when you're going to go take a shower. Um, Although maybe the nature of those particles are a little bit different, or the nature of those pollutants, VOCs, may be a little bit different. If you're going to be using hairspray, stuff like that, ventilating ahead of time, getting the current of air extracting out of your bathroom, and keeping it running for a bit too. Okay. Any others on that or no?
No, you're good. Yep. Thanks.
Sorry, Linda, go ahead.
Okay. So translating the data, this is, yeah, what goes on between the monitor and your sense of what it means is the big challenge. It's a huge challenge. So is it great? Is it good enough? How bad is bad? Does it, you have to panic if it's bad, or is it just, oh, I should do something in the next 5 years? So how to make that interpretation, and that's where we clearly saw that folks could get overwhelmed with the results. And in the and it's important to have that frame of reference. But what we see is that in order not to cause panic, it seems like in too many cases when people, the indoor air quality monitors might use a more conservative or less conservative, might use a more lenient interpretation of whether or not something is worth taking action because they don't want to create panic and be accused of, causing people to totally freak out. Um, yeah, I don't know if I'm being clear here, but like radon is a really good example where the EPA action level for years has been 4 picocuries per liter. But it's estimated that over half the people that die from radon-induced lung cancer experience levels that lower than that because there's so many more homes. So many more people times that lower level of exposure. So by all means, it makes sense to lower levels below that. The criteria pollutants that EPA measures that are outside are based on outside exposure, but our rule of thumb is always go as low as possible and not assume that there's some safe level, because what we're finding is there probably isn't a safe level. So the bottom line is to figure out what makes sense for a given household and home, and recognize that it's relative. What are your other priorities? What other things do you need to spend money on work first? Like paying the bills or buying food. So anyway, it's it's I think that is a perpetual challenge in that it's very important not to assume that just because an indoor air quality monitor might say, "Oh, you're in the good range," that's good enough, I guess is what I'm saying. Exposure over time is a really fun one because, well, it's all a matter of interpretation. You see a spike and it might be 50,000, for example, particles. But that might be the only spike you had 50,000 and your overall baseline level is really low. So I'll talk about that just in a second. But in many cases, if you try to do something with the data from one of these multi monitors that gives you, 10 or 12 things, and you download you're gonna get overwhelmed quickly with, well, how do I even make sense of this? We often see that there are too many variables and the changes are hard to interpret. But the main thing is, it is really important, I think, to be able to tell, did my actions make a difference? And the key thing there is to don't assume a really quick response. As I said, in terms of particles, it could be another factor. So you need to just look for longer term impacts, I think would be the takeaway. So as I said, spikes are a key one. Oops, skipping ahead here. Um, if you have any connected device, you'll be able to see a time series graph, whether it's on a map, like a purple air map, or whether it's on an app. And that time series is showing you, oops, oh, right here, something went really high. And it's very, very easy to focus on what caused that spike. So that's where the issue is. It's very helpful to know what caused the spike, but and in lots of cases, if you know what caused a spike, then you realize, oh, I could do something differently. But if you're only focused on getting rid of the spikes, you really could miss the sort of bottom line of what is the baseline. And this is where these are the things that typically cause, I don't know, maybe my cursor doesn't work here. Anyway, um, there are lots of things that can cause peak incidences, but I'll show you this one, next slide. This is just an example of the typical kind of time series plot you might see. And this is actually a low spike. It's only 7,000. And like from our perspective, you can easily see 40,000. So if this was a 40,000 spike, everything down here would be flat because basically there's a fixed area to put this graph in. And if it's linear, the scaling is going to be driven by your highest spike. So this could even change over time. So you could be misinterpreting your data just because you don't realize as you scroll from one day to another, oh, they just changed the scale because my spike changed. So, but this is an example of using a different scale, using a logarithmic scale. And by using a log scale, all of a sudden you can really see the interaction. And we really focus on this a lot because we want people to see, well, in this case, the bedroom is lower than the pantry. And you can also see the spikes, you can see relative impact with outdoor, but just important to recognize that the exact same data, and that's the point that's made here, is this is the exact same data in two different views. So recognize that that's powerful and that if you've got the ability or if you're shopping around, if there is the option of toggling back and forth between linear and logarithmic views, that can be very helpful. This is an example of just where we were giving feedback and we really wanted, I mean, we want people to be able to see the impact and this is our own uh, data explorer tool, but the notion of having the impact of a very inexpensive fan filter night and day because you will go from over here where everything is crappy, basically deep red is crappy, different locations, and you can see the immediate impact. So really helpful when you can see that impact. One problem is if you have a portable air cleaner that's got a sensor on it, those sensors, in our experience, haven't are not at the level that we would like them to be in terms of sensitives enough. I think they will be coming, but we usually recommend people don't run a portable air cleaner based on the auto setting because it won't run enough. It saves energy, but it doesn't run enough. Um, so on back to Rob.
Okay, so we just have some couple slides of resources, pretty basic, but important to arm you with some things to make a better decision for your application. This one is from AQ-Spec, so it's the Air Quality Sensor Performance Evaluation Center. And this comes out of essentially the mess that is Southern California's air quality. Southern California has notably pretty much the worst air quality in the country for a geographical region. And so South Coast air quality monitoring is a whole quasi-federally funded now or adopted now, state-funded and also privately funded group that does research on this. So they've been doing testing in this capacity for this AQ spec since 2014, specifically for monitors and low-cost monitors, or at least consumer or lower commercial grade monitors. They aren't doing this necessarily to say, hey, the EPA federal monitors that are, $30,000 in cost are not that great. why it's more that angle for consumers. And so what they do is they do a field evaluation period that's 8 weeks long, where they deploy it in a could be indoor, could be outdoor, but either way, someone's home essentially, or business workplace. They also do a lab evaluation where they can better control for high and low temperature settings, high and low humidity settings, high low wind. There's some other variables they use, but those are the big ones because those are the ones that affect air quality monitors oftentimes. And they also do mobile evaluation, where they will like strap it to a vehicle. Google Street View camera vehicles is one of them. They've done it with public transportation vehicles, some other ones like that. And they basically just drive the monitors around and see how they perform in like a real world setting. So check that out. Another resources that we have here is one of them already linked by Linda early in the slide, but it's EPA indoor air quality page, and they have a whole bunch of different sublinks under that that are super important. And another one is the US EPA air sensor toolbox. It gives a lot more context for maybe those more expensive monitors, some middle grade and lower cost monitors, what the data kind of means and what the context could be for a homeowner or just a regular consumer. And then we also have Maine Indoor Air Quality Council. I know there's a lot of questions I was seeing pop up about Maine specific, and here we are in Maine, so it makes sense. So yeah, Maine Indoor Air Quality Council, Christy, has a great amount of resources related to things that we might see in Maine: mold, temperature condensation, wood smoke, stuff like that. And then ROCUS is our webpage, and we have different areas of information and topics. One really good one is for range hoods, so check that out on your own time as well. So it's kind of like, okay, we have the presentation, you gave us resources, you talked about these specific pollutants, you talked about monitors that may not be living up to feasibility, but what do you do now? So you can engage with community resources. You can purchase or borrow monitors for your own usage, or to lend to other people. And you can contact professionals. Maine Indoor Air Quality Council has a great network of contractors and other professionals that can do testing, air assessment, blower door tests for tightness relating to HRV, ERV. I saw a question about that. Remediation, if you do need mold issues worked on or radon issues worked on, and then interpretation of what does it all mean and what can you do with it.
Rob, we are just about out of
Just one.
time. So I'm hoping that we maybe have time for one more question. I know you've received several there, Christy.
Okay, sure.
Is there one that jumps to the top for you?
Well, I think there've been a lot of questions associated with ventilation and the role of ventilation. And I was just curious if Rob and Linda might want to address to a homeowner here, what sort of kind of thinking about creating extra ventilation in your homes might like some options for homeowners. I think that would be a useful thing to address.
It's probably the thing we're more challenged with. Many of the homes in our cohorts are very well ventilated houses. So like their parts per million or CO2 parts per million probably won't get above 700. So I mean, you don't need a balanced mechanical ventilation system if the house is that leaky. So how do you address the fact that what we really want are houses tight enough that you need ventilation, but then if you make a house tighter or build it like it should be built, then mechanical ventilation basically is giving you control, and that's what you absolutely want is a controlled ventilation system. That's what's to be shot for. But by all means, the first thing to do is minimize your sources. So in putting all this together, we often find that there are many people that could probably greatly enhance their ventilation by just taking the middle step of making sure their point source ventilation is adequate, because they could use that to take care of the worst offenders, which would be cooking and probably what goes on in the bathroom in terms of bathing and all the other products you use. But then anytime they need a boost, they could get a boost. But that's still very suboptimal. And it's a council that does such fantastic work guiding people on how to do effective, balanced ventilation. I don't know,
That's a
Rob, if you want.
great note to end on. I hate to cut it because we have so many more questions that we could dive into. But I do want to thank you all for being with us today and for sharing so much good information, and including all of the resources you shared. So we will send a follow-up email to everybody who registered and include some of these links that you included, as well as we'll link to all of the indoor air quality articles that Christy has written, Christy and her team have written over the years that are published on our website, greenmainhomes.com. So we'll send those out with the follow-up email. So thank you again to our sponsor, Royal River Heat Pumps, and to Maggie Perkins, who's been handling everything behind the scenes. If you're interested in learning more about future home and energy chats and or checking out the recordings for this session and all of our past sessions, those are also available on our website, greenmainhomes.com. And as Christy mentioned, if you do have any questions we didn't get to today, she has volunteered to field them. That's one of the things she does with the Maine Indoor Air Quality Council. So please reach out to Christy with any questions. And lastly, there will be a short survey that pops up after the session, and we'd love your feedback. And thank you again, Rob and Linda, for joining us. This is really fabulous to have you here in Maine, and so great to have you share so much information with us.
Thank you for having us.
Thank you, Heather.
Yep. Thanks so much.